If you put the magnet together, they will be attracted if they have different pole. And then the freely suspended magnet always shows north-south direction. So that's why even when the boy try to make the magnet to show to another direction, it's still showing the north-south direction. Okay, these are the properties of the magnet. Okay, next we have to go to the magnetic field. So the magnetic field, what is the magnetic field? So the area around the magnet with magnetic force is known as magnetic field. Okay, the one that can able to attract the magnetic material lah. So around here. So around here we have the magnetic field. The area around the magnet with magnetic force. So here they have the magnetic force lah. Okay, this we call as the magnetic field. Okay, dekat sini dia tak boleh attract. So it will here. It can be attracted but it's only a very weak, little weak one lah. So this one is stronger. Magnetic field is here. Okay, next look at page 159. So activity 7.9, to show the pattern of magnetic field, we use the iron fillings, the black color chemical lah, and then we put on the cardboard, and then we put the bar magnet beneath. So and then we can see the pattern lah is forming around the magnet. Okay, this because the iron fillings will be attracted to the magnet. So dia akan nampak satu pattern lah, satu corak of the magnet. It depends on the type of the magnet lah that we use. Okay. Here we have the characteristic. Just now is the properties of the magnet. These are the characteristic of the magnetic field. Okay. Characteristic of the magnetic field, we have that the magnetic field lines begins from the north pole and end at the south pole. Okay, start from north and then end at the south. So N and S. N is the north, S is the south. Okay, so from N it goes to S like that. That's the pattern. Okay, so the magnetic field lines never meet or cross. So if you are drawing this line, you need to draw it carefully. So dia tak boleh meet or cross one another. Mesti ada satu laluan sajalah. This one only for one. Dia tak boleh double lap. Okay, on one another. Only one distinct line. Okay, and then the magnetic field lines are closer to one another where the magnetic field is stronger. So here, sini dekat kan. The magnetic field lines are closer here compared to here. Sini jauh, sini pun jauh. So here they have stronger magnetic field compared to this one. Okay, here. The closer the magnetic field lines, the stronger the magnetic field. So these are the three characteristics of the magnetic field lines. Okay. So if we broke a magnet into two pieces, do they still have two poles or not? Or only they're left with one pole? If we break the magnet, they still will have two poles, which are the north and the south pole. Mesti ada dua pole juga even we break them apart. Okay, mesti ada dua juga. That's the magnet punya properties. Okay, and then here a magnetic field between two like poles, okay, pole yang sama, will produce a neutral region, the X here, which is free from the effect of any magnetic force. Okay, like this, they are repelling one another. So these are the neutral region. Okay, at the center here, the neutral region, which is free from the effect of any magnetic force. Okay, dia tak ada apa lah dekat sini. At the center here, because the like poles will repel one another. Okay. And then here we have the electromagnet. Okay, what is electromagnet? The electromagnet is a type of magnet that has temporary. Okay, temporary tu sementara, temporary magnetic effect. Okay, when electric current flows through it. So when there is the electric current, so they also have the magnetic effect. Maksudnya it will attract the magnetic material lah. Okay, only in the temporary. But if you have switch off the current or if there is no current flowing, so there's no magnetic effect lah if you turn off the current. So if they have the current, when the current is flowing, there will be a magnetic effect along the conductor, along the wire lah. Okay, it's only for temporary. Okay. Okay, so I want you to find out about the electric bell. How does the electric bell function? Okay, this one we will discuss on our next class, the electric bell. How does it function? Then here the users of the right hand grip rule. Okay, this one that I ask you to remember the direction of the current and the direction of the electron, right? So the direction of the current is important because it will determine the direction of the magnetic field. So the pattern of the magnetic field depends on the shape of the conductor used. Okay, depends lah what type of conductor, what type of the shape you use. Ada yang panjang ke, ada yang melengkung and so on. Okay, depends on the shape of the conductor. The conductor here is the wire lah, the wire, we use the wire. So for example, the magnetic field lines produced by a straight wire. Okay, look at here the straight wire, wire yang lurus. And coil wire are concentric circle. Okay, dia dalam bulatan. Magnetic field lines are closer where the magnetic field is stronger. That is the characteristic of the magnetic field just now. Okay, the strength of the magnetic field reduces as it moves away from the center of the conductor. Meaning dia menjauh lah. It move away from the center of the conductor, which is the wire in this case. The pattern of the magnetic field produced is not affected by the direction of the current that flows through the conductor. So here you can use your right hand grip rule. Okay, the name of the rule here is the right hand grip rule to determine the direction of the magnetic field. So this one you can demonstrate by using your right hand. Okay, and then this one is the wire lah, the conductor in the straight wire. Okay, the straight conductor, and then the thumbs showing the direction of the current. Your thumb showing the direction of your current, and then your four fingers will showing the direction of the magnetic field. So here they flow in the concentric circle. Okay, dalam bulatan lah. Okay, from here ikut you punya jari, 4 jari ni lah. Okay, dalam bulatan here. So the direction of current, they flow from positive terminal to negative terminal, right? Okay, from positive to negative. So this one, it flows through your thumb and then you get your direction of the magnetic field. Okay, this is for the straight wire. Okay, what happen if there is a coil wire? You need to turn your hand lah. You need to turn your hand. So this one from the straight wire, from here. So your thumb showing upwards. Okay, and then you move your thumbs to your right. Okay, and then it move downwards. Okay, move your thumbs downwards and then this shows the direction of the magnetic field. So in the concentric circle, ini secara membulat lah. So this one, the closer lines showing the stronger magnetic field. Okay, the one that is further from one another showing the magnetic field is weaker lah. It's weaker when they are further from one another. When they are closer to one another, we can say they have stronger magnetic field. So this one for the straight wire. Straight wire is very easy lah. Okay, this showing your thumb showing upwards. This one starting from your thumb and then you turn your thumbs downwards. Okay, pergi bawah. That's the direction of the current. Okay, this is how you draw the direction of the magnetic field. And then for the solenoid ni it's like this lah, the solenoid. Okay, macam ni. This is the solenoid. So you need to use like this. Okay, the current from the here. Okay, the current move from here and then they move in this rotation. Okay, the rotation until the current went out. So the magnetic field produced is at the center of the solenoid. Okay, at the center of the solenoid. So different type of conductor, different shape of the conductor will give different pattern of the magnetic field. It depends on the um, conductor, depends on the type of the conductor. Okay, they are not the same. So that's why you need to know the direction. Where is the direction? And then you can use your right hand grip rule. Okay. So here the solenoid polarity can be determined by observing the direction of the current flow. Okay, the direction of the current flow. The current that flows in the anti-clockwise direction is the north pole, whereas the current that flows clockwise is the south pole. Okay, this one is the positive. Okay, the current flowing from positive to negative. Okay, from this one, and then it flow around the solenoid, and then it goes out the current. Okay, so these are the pattern that you need to remember. And then this one, does the current flow affect the strength of the magnetic field? This one, if we have time, we can carry out the experiment lah, so that you can see it, how it works. Okay, and then the last one, the application. Application of magnets and electromagnets in daily life. Okay, these are the three examples. The needles of a compass uses a magnet to show the direction of the pole. And then also the credit cards and debit cards have an electromagnetic strip that stores information. So it can read the information through the electromagnetic strip. And then the magnetic lock on doors uses an electromagnet to lock the door automatically. So we don't have to lock the door lah, because it already locked automatically by using the magnet. Okay. Okay, any question? So these are about the magnetism. If there is no question, you can continue with the homework. Page 106 and 107. Okay, page 106 and 107 of your workbook. Okay, later on our next class, we will discuss lah about this answer. Okay. If there's no question, we shall end our online lesson here, and you can continue with your homework. Okay, thank you, class.
Thank you, teacher.
Thank you,
Thank you,
teacher.
teacher.
Bye
Thank
bye.
you, teacher.
Thank you, teacher.
Bye, teacher.